for a fight, or we can say it is the last occupied territory of an individual army also. After that, the enemy territory, if it's the enemy country, if like India we are surrounded by hostile neighbors, then it generally becomes a battlefront. So in the geography, what is a weather front? Now we are not concerned with the front of a building, neither are we concerned with the battlefront. We are concerned with geography, that is the fronts which are formed in the weather front. Now look at the two diagrams which are shown here. The first diagram shows the region of Europe, UK, which I have tried to show you very diagrammatically, and there is no need to draw this diagram in the examination. In this, there is a warm westerly wind which is moving towards from the subtropical high pressure belt to the subpolar low pressure belt in this direction in the northern hemisphere. So these are westerly winds, and what are the characteristics of the westerly winds? Because they originate in the subtropical high pressure belt, they are obviously warm winds. On the other hand, there are some winds which originate in the polar high pressure belt, and they come towards the subpolar low pressure belt. These winds are known as polar easterlies, and obviously they are extremely cold wind. Now both these winds, they come together and they become face to face, or in the simple language we can say that they converge or they collide at a place which is known as subpolar low pressure belt, because from the north, that is from the polar regions in both the north and the south hemisphere, the cold polar easterlies originate and they blow towards the subpolar low pressure belt. And from the south and from the near the equatorial regions, in the subtropical high pressure belt, warm westerlies originate and they come here to the subpolar low pressure belt. So the subpolar low pressure belt, which lies here between 60 to 65 degree latitudes, it is a zone of convergence of two different wind direction. So initially we can see in the diagram the cold easterly is coming and the warm westerly is coming from the northern and the southern side respectively, because I have shown you in the diagram only the northern hemisphere. Over the period of time, the cold wind tries to penetrate in the areas of a warm air, while the warm wind will try to penetrate in the area of a cold air. So as a result of this, there is we can say convergence or collisions. That means these two winds will come face to face and they will try to penetrate each other's area. Obviously, the air becomes in such a way that there becomes an area where the cold wind dominates, or it tries to enter into the area of a warm air, and there comes another area where the warm wind dominates and it tries to enter in the area of a cold air. Now such a convergence of two contrasting winds, why do I say two contrasting winds? Because both these winds differ in their properties. That is, these winds are cold winds, cold polar easterlies. Because of extremely cold winds, they are heavy winds. Cold air is a heavy air. They are icy winds. They have high pressure. On the other hand, the warm winds are lighter winds, because warm air is a lighter air. See, again, listen to my words, lighter winds. What this will help you. Cold is a heavier wind, warm is a lighter wind. This will help you while studying the fronts again. Now, warm air is a lighter air. It blows with much more speed, because being lighter, it blows very near the ground surface. And it is generally a dry air, or it can be a moist air also, because humidity capacity is directly proportional to the temperature. Now it depends, if it's on the ocean, it will be moist. If it's on the land, it will be dry air. Now this is just a fraction, or you can say this is just a representative diagram. Obviously it is happening all over the world. This is happening in the subpolar low pressure belt. So there will be two areas where the two winds will try to penetrate into each other areas. The area where the cold wind dominates, the area where the cold wind is active, which I have shown you in the red triangle, small, is known as a cold front. While the area where the warm wind dominates, or the warm wind is active, which is shown as a semicircle, and this is how the geographical representation of the individual fronts are, which are shown in the form of a semicircle, is known as an warm front. So this is how the front is formed. Then how the front is formed: when the two area winds try to converge into each other's territories, there comes a position or comes a point where the cold wind is more active than the warm wind, and the resulting into formation of a cold front, and the warm wind is more active than the cold wind in some areas, resulting into formation of a warm front. So then what is the definition of a front? Now when the air is active, it does not mean that both the winds will mix in a proper way, in a symmetrical way. Obviously when I say cold air is heavier than the warm air, if these are the two air masses which are coming, and if you consider this as a warm air and the duster as a cold air, when they will converge, the warm air will try to rise upwards than the colder air, while the colder air, because it is heavier, will try to come downwards. So what is a front? Then how will be the rising? Rising won't be abrupt rising, it will rise as per the dimensions of a cold air, and the cold air will also come down. So what is a front? Then how can we define the front? Then front can be defined as a sloping boundary. That is why I showed you this diagram. Why? Because it is a boundary, it is a sloping boundary. Why the slope is formed? Because the cold air being heavier tries to come downwards, while the warm air being lighter tries to rise upwards. So as a result, a sloping boundary is formed. Such a sloping boundary between two contrasting but converging air masses is known as a front. So what is a front? What is a proper definition of a front? And you mind it that this is an important topic both for mains as well as preliminary examination. I will tell you what are the importance for both the examination. So what is a front? Front is a sloping boundary, which it is a sloping boundary which separates two contrasting how it is contrasting in the terms of temperature, obviously in the terms of pressure, two contrasting but converging air masses, So it is a sloping boundary which separates two contrasting but converging air masses. So contrasting but converging air masses are separated in this kind of a front. Now what are the air masses? It is a large volume of an air is known as an air mass. So when these two contrasting but converging air masses, that means when they come together, there is a sloping boundary which is formed, which is known as a front. What is the common characteristics of a front? What will be the characteristics of a front? When there are two contrasting air masses, obviously the characteristics will be in the front. There are large variations in the terms of temperature, in the terms of pressure, in the terms of humidity, so the common characteristics of a front are large amount of difference in the terms of temperature, in the terms of pressure, in the terms of humidity, and shift in the wind direction, the terms of wind direction, are the chief characteristics of the front. So there are large amount of differences in the terms of humidity, in the terms of pressure, in the terms of wind direction is observed in the front. So again repeating, what is a front? It is a sloping boundary which separates two contrasting but opposing air masses, two contrasting air masses. Now here these two contrasting air masses should be convergent, should have a convergent flow, should have different type of physical characteristics. Now why I am again repeating this? Because many times in the preliminary examination one question is asked, which I will soon discuss. Why? Because if you remember your wind direction, if you remember your wind belts, there are two pressure belts in the world where there is a convergence, but front is formed only at one kind of a pressure belt. So now what are the conditions for the formation of a front? What will be the conditions for the formation of fronts? Now see, the air circulation is in many different directions. If we look at the pressure belts in the world, the air circulation can be this way, that is from a single pressure belt, winds diverge in two different directions. It can be this way, in a single pressure belt, winds are converging. For example, any low pressure belt from different directions. It can be in this form, that is the wind are in circulatory motion. It can be in this form, the winds are coming inside a low pressure belt. So there can be different directions for the different ways in which, there can be many different ways in which the winds will blow. They can diverge, they can converge, they can come in a circulatory manner like a cyclone, or they can go in a circulatory manner. In which, what is the condition for the formation of a front? As we say, in the front there should be two contrasting and opposing air masses. Are this opposing? They are moving away from a common point. So can we say that there is a convergence? No. This is a divergence. So this is not a condition for the formation of a fronts. The second is contrasting air masses. Yahan pe, in this, the two airs are coming together and they are colliding against each other. That is, convergence is there. So as per our definition, this is the way for formation of an front. Here, the air is going in a circulatory manner. Even if there are two different types of airs, these all are going in a circular manner. In a circular manner, there is neither convergence nor a divergence. But our definition says that there should be convergence of an air mass. So even this is not the way. Now the fourth, here you can say there are two different type of air masses and there is a low pressure center over here, and the winds all from all other sides are attracted towards a low pressure center. But again, there is no proper convergence of a wind along a line. It is along a point. In the point, when the convergence occurs along a point, we call them as cyclones and not as a fronts. So even this is not a condition for the formation of an fronts. So what is the basic condition for the formation of the front? It is the second one. So one of the basic conditions, now this is the preliminary question also, that what will be the conditions for the formation of a front? So the formation of a front, first is the convergence of an air mass. So the first condition for the formation of the front is the two air masses should converge. The convergence of an air mass is the first condition for the formation of an front. Now what kind of convergence is there? Convergence along a line. The convergence should be along the line. And for convergence to occur, the air mass should move in the air mass should have opposite directions. Towards each other. You don't have to write each and everything in the examination, because in the examination, if the question is asked, it will be directly on the conditions for the formation of a front or what are the fronts. So the convergence along a line is one of the basic conditions for the formation of an front. Now the second is, once the convergence is occurring, if you remember your wind belts of the world, this is a subtropical low pressure belt. This is tropical low pressure belt. Then there is a subtropical high pressure belt. Then there is a subpolar low pressure belt, and then there is a polar high pressure belt in both the hemispheres. Now, how are the wind directions here? Trade winds, they blow. Warm trade winds, they come towards the equatorial low pressure belt. What we call them as an easterly winds in both the directions. That there is a convergence here. Now, this is an equatorial low pressure belt. There is another wind which blows as westerly winds. It also originates in the subtropical high pressure belt and blows towards the subpolar low pressure belt in both the hemispheres. And lastly, there is an extremely cold wind known as easterlies, which blow from east towards the west. So in the world level, there are two areas where the convergence occurs. One is the equatorial low pressure belt. There is a convergence. What we call them as a belt of doldrums. There is a convergence at subpolar low pressure belt. While the other, that is the subtropical high or the belt of horse latitudes, there is a divergence here. Again at here, subtropical high, again there is a divergence here. Now if you remember, again we will revise, this is known as the belt of a doldrum, that is the equatorial low. These are known as horse latitudes, the zone of divergence. Subpolar low pressure belt is known as the frontal zone, then both the latitudes. So this is the area of fronts in both the latitudes. While this area is known as an area of a polar high, that is extremely high cold temperature, and so high pressure belt is formed in this region. Now coming to your fronts topic, we can see there are two regions where there is there is a convergence. One is equatorial low, then there is a subpolar low in both the areas. But when we study the fronts, we will study that the fronts are formed only in the subpolar low and not in the equatorial low. What is the reason? And this is what is asked in the preliminary examination generally, that why in the equatorial low pressure belt there is no formation of a fronts. Again, come to your definition of a front. There should be convergence of an air mass. That is the air masses should converge, but this air masses should be contrasting in the terms of temperature, in the terms of, obviously if the temperature difference is there, pressure and moisture difference is also there. So what is the basic definition of a front? That is the two contrasting air masses. Now coming to the equatorial low pressure belt, this is a red color wind which is known as trade wind, which blows from subtropical high pressure belt in the north to the equatorial region. In the southern hemisphere also there is a red color wind, that is I have shown you in the red color. Again it is a trade wind which blows from subtropical high pressure belt to the equator. So even though there is a convergence, both these winds are of same type, and hence there is no formation of a front, because by our definition the front should be having a contrasting properties. The wind should be having a contrasting properties. So there is no formation of a front in this region because both the winds are having the same characteristic properties. On the other hand, in the subpolar low pressure belt, one wind is greenish in color, that is the westerly wind in both the hemisphere. What is the characteristics of a westerly wind? It is a warm wind because it originates in the subpolar, in the subtropical high. The other wind is the bluish in color, that is extremely cold polar easterlies. So here this both are converging, and because they are converging and also they are having contrasting properties, there is a formation of a front. So the second condition for the formation of a front is the two air mass should have temperature and obviously pressure difference. The second is the two converging air masses should have contrasting temperature. Obviously, if there is a temperature difference, the pressure difference is there, and as I told you, moisture difference is also there. So these are the two conditions for the formation of a front. First condition is there should be convergence of an air mass. This explains why the fronts are not formed in harsh latitudes, because there is a divergence, not convergence. This explains why the fronts are not formed in the polar high pressure belt, because the wind moves out from there. It is not converging, again a kind of a divergence. The second point is that the two converging air masses should have contrasting temperatures. That is, the two converging air masses should have contrasting temperatures. So there should be greater temperature difference between the two air masses, and this explains why, in spite of convergence, again remember this, why in spite of convergence there are no fronts in the equatorial low pressure belt, because both the converging winds are the similar kind of trade winds. Preliminary point is answered here. Why there is no fronts in the equatorial low pressure belt? Because the second condition is not satisfied, because both are trade winds and both are having similar properties. Okay, so here is the two conditions for the formation of a front. Now after this, why are we studying the fronts? Because when the fronts are created, it is the first step in the formation of a temperate cyclones, and the death of a front is the last stage in the temperate cyclones. That is, the creation of a front results into formation of a temperate cyclone, while the death of a front results into destruction of a temperate cyclone. Because we are living in the subtropical region, we do not experience such kind of a climate regularly. But this year's preliminary questions, that why there is a winter rainfall in India, explains somewhat the fronts. That is, people who are living in northwestern India, in the northern part of India, do experience the fronts and the related weather pattern when they get winter rainfall due to the cyclones which are brought in India by the westerly winds. Okay, so what are the stages in the formation of a fronts? Frontogenesis. There is a term. What do you mean by genesis? Is a creation of something. So frontogenesis is a birth or creation of a front. While frontolysis, lysis means death of something, frontolysis is associated with the death of a front. Frontolysis means death of a front. As I told you, frontogenesis is the first stage in the creation of a temperate cyclone, while frontolysis is the end of a life of a temperate cyclone, end of a front itself. If we try to study the fronts, if we try to classify the fronts can be classified in 4 different ways, though we are mostly concerned with the 3 types of fronts. But when we classify, if they ask you the question, classify the fronts can be classified. Obviously, you will have to, even if the question is classify the fronts, then you will have to give the definition of a front, and then the fronts can be classified in following ways. There is a warm front. Then there is a cold front. There is an occluded front. And then there is a stationary front, though geographically speaking this is not a front, but just we as human beings have a habit of simplifying and classifying everything. So we have made a non-front as also a front, as a stationary front, though geographically it is not a front, so it is a stationary front. So the fronts can be classified in the warm front, cold front, occluded front, and the stationary front. Now studying the first warm front. What do you mean by warm front? Then what do you mean by cold front? I think that by looking at the previous diagram you have an idea of what a warm front is. Warm front is when the warm air invades in the territory of a cold air. What is a cold front? When the cold air invades in the territory of a warm air. What is an occluded front? Occluded front is associated with the frontolysis, that is the death of a front. That is when will the front die? When from the ground surface the warm air is totally removed and its place is taken by the cold air, means there is no sloping boundary, then there is a cold air below and warm air above. Obviously, there is no such sloping boundary, there is no such convergence. We call such as a death of a front or occluded front. And stationary front is a front when both the winds do not converge but they flow parallel to each other. There is a concept known as geostrophic winds. That is when the winds move parallel to each other. Such winds are known as when the winds move parallel to each other, it is known as a stationary front. So, we'll study each of this front in detail. What is warm front? As I told you, warm front is formed when in the area where the warm air is active. If the area when the warm air is active, what area will be the area where warm air is active? Warm air will be active in area where it voluntarily invades that area of a cold air. That is in the previous diagram, the semicircle area. So, forms in area where warm air is active and because it is active and invades the territory of cold air, and invades the territory of an cold air. So forms in an area where the warm air is active and invades the territory of an cold air. Now let's see what happens when the warm air is active and it is invading the area of a cold air. I will take two different colors here to justify my point. If this is a ground surface, in geography, if you are drawing diagrams, you should draw a ground surface like this. Well, if this is an area where there is a presence of an cold air, I'll show the blue color by cold air. This is an area where there is a presence of an cold air. If this area where there is already a presence of an cold air, if the warm air comes in this area, we call it as a warm front. So what happens when the warm air comes? When the warm air comes in the area of a cold air, we see that the warm air is lighter than the cold air, and therefore it voluntarily rises upwards in the territory of an cold air. It tries to go upwards. Now such a sloping boundary which is between the cold air and between the warm air here is known as an warm front. So this sloping boundary is known as an warm front. Now why the warm air is going upwards? You already know that warm air being lighter, it rises upwards, and the cold air being heavier, it comes downwards. So in the area where the warm air is active results into the formation of a front known as warm front. In the warm front, the warm air, because it invades the territory of a cold air, after going into that territory, it voluntarily rises upwards along a gentle slope. Now you see this slope is a gentle slope as compared to the cold front slope, which I will show you in the next diagram. And because when the warm air is rising upwards automatically, obviously when the warm air rises upwards, it is cooled, and resulting cooling results into formation of clouds. And therefore there are cloud formation in the form of nimbostratus clouds, and then there is a rainfall. So what happens in the warm front? In the warm front occurs in an area where the warm air is active and invades the territory of a cold air. The warm air rises upwards, being lighter, it rises upwards along a gentle slope. Because it rises upwards gently, obviously it is cooled at a slow place. Because of the cooling, there is formation of a cloud, but because it is cooled at a slow pace, there is a formation of nimbostratus clouds. Now the nimbostratus clouds, whenever they are formed, they give rainfall in the form of, they give light rainfall, not very heavy rainfall. So nimbostratus clouds are formed and they give rainfall in the form of a drizzle, in the form of a light rainfall, which, because the rainfall is light, which occurs for a longer duration of a time. And to show geographically, we generally show in the examination, you should draw the diagram which I am drawing now. That is what occurs in the cold front, in the warm front. So this is a ground surface, this is a cold air here. The warm air is invading the area of a cold air, and because it is invading the area of a cold air, it is voluntarily rising upwards, and because it is rising upwards, there is a formation of nimbostratus clouds. While this sloping boundary between the cold air and warm air is known as warm front. You don't have to show the clouds in the examination because this diagram is for drawing in the examination, otherwise it will look too much of a, then if you try to show the clouds here, it won't look too tidy. Your diagram should be tidy also in the examination. So if you try to draw the clouds, I think it will look it won't give a very clean impression to the examiner. Obviously there is a rainfall which occurs. So except for rain and clouds, this is the diagram which you should draw in the examination. So what is occurring in the warm front? The warm air being lighter rises upwards along a gentle slope. Because it rises upwards, it is cooled slowly, resulting into formation of nimbostratus clouds, resulting into formation of an nimbostratus clouds. How is the weather associated with the cold front, with the warm front? The weather which is associated with the warm front, because the rising warm air is cooled gently or slowly, the warm front is associated with light to moderate precipitation, or rainfall which occurs for a longer duration. So it is associated with light to moderate precipitation which occurs for a longer duration. So this is the warm front. Very easy to understand, I hope so. What is happening here? The warm air is coming in the area of a cold air. Because it rises upwards voluntarily. This boundary between warm air and the cold air is known as a warm front. What happens in the warm front? Because the air is cooled adiabatically, slowly, there is a formation of clouds which give rainfall for longer duration and covers a larger area, because as per the slope, the rainfall will occur. What is the kind of a rainfall? The rainfall is not with cumulonimbus cloud, but with the nimbostratus clouds, and therefore it is an moderate rainfall or light rainfall without lightning and thunder. So this is the warm front and warm front precipitation, okay, or the weather associated with the warm front. I hope so you are writing down these points, because this are all the points, and this is where your both prelims and the mains are covered. Now the next kind of a front is an cold front. Cold front. What will be the cold front? Cold front will be an area where the cold air is active. And what do you mean by active? It means that it invades the territory of an warm air. See, there are very two basic, there is large amount of difference when the warm air is being active and when the cold air is active. For example, if you can see, there is a ferocious animal or ferocious dog which is sitting in a lane. What we do? We avoid that lane, and because voluntarily we know that, and we go through different lane. But after going inside the lane, if you don't know that the ferocious animal is sitting, ferocious dog is sitting, the dog will chase you and you will start running, because here the dog is trying to chase you. You run to save your life. The same thing, same difference here can apply for the warm and cold air. In the area where the cold air is active, we will see what happens. If this is again a ground surface, and if this is an area where there is a warm air, and its territory is invaded by the cold air. Its territory is being invaded by the cold air. Now, when the cold air comes, cold air is heavier, and so it comes in the territory of a warm air. But the territory is already occupied by the warm air. So what has the cold air has to do? The cold air, as I told you, the ferocious dog, you are invading his territory, you will have to run. Similarly, when the cold air comes in the territory of a warm air, the warm air does not voluntarily gets displaced, but the cold air picks the warm air and throws upwards. In our layman term, in the geographical term, the cold air comes downwards, invades the territory of warm air and displaces the warm air vertically along the slope. So here, when it comes in the territory of a warm air, it will try to throw the warm air upwards, and hence the warm air is thrown upwards along a very, very steep slope, because here this area is now being invaded by the cold air. So it will throw this warm air and it will occupy this warm air, this territory. So the warm air is being thrown upwards, and as you see, the warm air is being thrown upwards more or less vertically, and as a result, the sloping boundary between warm and cold air is known as a cold front. Now, when the warm air is being thrown, we can see in the diagram, it is being thrown vertically upwards. Whenever the air rises vertically upwards, it is associated with the formation of our famous clouds, which are known as cumulonimbus cloud. So large amount of cumulonimbus clouds are formed when the air is thrown vertically upwards, and whenever there is a cumulonimbus cloud, it gives very, very heavy rainfall. Whenever there is very heavy rainfall, it is because of the cumulonimbus cloud, it gives very, very heavy rainfall associated with obviously lightning and thunder. Why the lightning and thunder are formed? Why is the lightning formed? Because of the Charge difference. Generally, there is a positive charge in the upper atmosphere and negative charge in the lower atmosphere, and this charge differences results in formation of a lightning, and similarly it also results in the formation of a thunder. It has been asked in the preliminary examination in the 2013 as well as 2014 paper. I will discuss this as a separate topic, very small topic. That is what is, though it is more of a general science topic, but still we will discuss it in geography. So here, coming to in the cold front, because the cold air throws the warm air upwards more or less vertically, there is a formation of a cumulonimbus cloud. Whenever the cumulonimbus clouds are formed, it gives very heavy rainfall along with lightning and thunder. But you remember, the cumulonimbus clouds are associated with heavy rainfall but of a shorter duration. For a small and does not cover large area, because you see the slope here is not covering much larger area, it is covering only a smaller area. On other hand, the warm front slope was covering much larger area. Yahan pe there was formation of an nimbostratus cloud. So they used to give rainfall in the form of an drizzle but covering a large area. On other hand, cumulonimbus cloud, cold front mein, this is diagram for cold front. There is a formation of an cumulonimbus cloud, and it gives very heavy rainfall but of a shorter duration, covering a shorter area. So what is in this cold front and what is the weather associated with the cold front? You know that. What is the cold front? In the area where the cold air is active and invades the territory of a warm air. So it is formed in an area where cold air is active. And invades the territory of warm air. And it invades the territory of an warmer air. In such areas, cold air being heavier, displaces the warm air from the ground surface. Vertically from ground surface. Therefore, cold front is associated with steep slope, with steep slope, with the steep slope. How will be the weather? Now in this weather, because the cold air is displacing the warm air along a steep slope, therefore the warm air is cooled at a very fast rate. At fast rate. Therefore, there is a formation of cumulonimbus cloud. Therefore, there is a formation of cumulonimbus cloud, and whenever the cumulonimbus clouds will be formed, as I have told you numerous times, it is associated with heavy rainfall, along with lightning and thunder. but of a shorter duration. But of a shorter duration. But it is of a shorter duration. So these are the points associated with the cold front. Obviously, we are not expected to draw this diagram. It should be a neat diagram, not a. So what will be the diagram here? The cold front diagram is this way. And as I told you, the diagrams are so simple. So if the question comes in the mains examination, you are expected to draw the diagram. So here, this is a cold front slope. The cold air is invading the territory of a warm air. And because it is invading the territory of a warm air, it is displacing the warm air along a steep slope. So, warm air, cold air, and cold front. This is in cold front, while the other is the ground surface. So this is the diagram you should draw in examination. So what is a cold front? From in the area where the cold air is active, the cold air being heavier, it displaces, see the words are not gradually rises, it displaces the warmer air vertically from the ground surface. Therefore, there is a formation of a steep slope. Due to the formation of a steep slope, there is a fast rate of cooling of the warm air, formation of cumulonimbus clouds, and the weather pattern associated with the cumulonimbus clouds. Now, we see this is what we have studied till now. That is, there will be warm air, cold air, displacement of a warm air, and cold air itself. So, what is going to happen in the end? Whether it is a warm front or the cold front. If it is a cold front, on the other hand, if it is a warm front, so even in the warm front, the warm air will rise upwards voluntarily, while on the ground there will be cold air. While the warm air will rise upwards. Such a front is known as warm front. This is what we have studied till now. So in the end, what is going to happen? Whether there is a cold front or whether there is a warm front, we are, in both the diagrams, we are seeing that the warm air is rising upwards, whether it is a cold front or whether it is a warm front, and the cold air, because it is heavier, it is going to stay on the ground surface. So in the cold front, the cold air is voluntarily coming downwards, while in the warm front, the cold air is not displaced from its original position. So what will be the end result of both these diagrams? In the end, what is going to happen in any kind of a front? It will be the area, there will be cold air below and there will be warm air above. There will be warm air above. So this is going to be an end result. So again you see in the end there will be cold air below or the end there will be warm air above. Whether it is a cold front or whether it is a warm front. In the warm front, the warm air will voluntarily rise upwards, as you can see here in this diagram. While in the cold front, the cold air will displace the warm air above. But the end result is cold air on the ground surface and warm air above. So this is the end of a front or the death of a front, and it is known as an occluded front. Occlusion or death of a front. So in the occluded front, though it is not a proper front, but just for our classification, we are saying occluded front, and in the occluded front, when it will occur, when the cold air completely displaces the warm air from the ground surface, it is known as an occluded front. Geographically, it is a part of a front topic, but geographically it is not a front, because यहाँ पे there is no convergence. Cold air नीचे है, warm air above है, warm air will keep on rising upwards, and there is no converging air circulation, so it is not a front. So the death of a front is signified by an occluded front. When does it occur? When the cold air is completely displaces the warm air from the ground. Or, in the geographical language we can write, it occurs when the cold front completely overtakes the warm front. That means the cold air इतनी active हो जाती है that it completely overtakes the warm air, resulting into formation of a cyclones, which I will show you in geography through diagram, climatology through diagrams at the end in the near future. So here the next is an occluded front. Occluded fronts. What is this in this occluded front? It occurs when cold air completely displaces the warm air from the ground. Or we can say when cold front overtakes the warm front. As I have shown you in the diagram, what is going to occur? The cold air will be there on the ground and the warm air will be above. So front nahi hota. So the occlusion of a front signifies, this stage signifies frontolysis, death of a front. Or frontolysis. Or frontolysis. So nothing much, but death of a front is known as an occluded front. Now how to show it in the examination? Because you will have to write it in the examination. The diagram for the examination is this, that there is a ground surface. This is a ground surface. On the ground surface there can be both cold front and the warm front. Whatever the condition is there will be cold air below or cold air below, and there will be warm air above. There will be warm air above. So this is the diagram for occluded front, that whatever is going to happen, there will be cold air below and warm air above. Obviously iske baad there is no front, it is the death of a front. So initially the two air masses will converge, they will try to invade in each other's territory, resulting into formation of cold front and warm front. Over the period of time, the cold air will completely remove the warm air from the ground, resulting into formation of an occluded front. Now sometimes Now sometimes you know that geography, climatology, especially weather, in fact our Indian monsoon also, we try to study in very simplistic pattern. But it is an interplay of many factors. Local temperature difference, this temperature differences, moisture differences. So sometimes the wind for a period of time change their direction. So instead of convergence, they start flowing parallel to each other. Such a front, when they start, it does not occur all the time. It occurs only for a temporary period of time. So the area जहाँ convergence होना चाहिए. So instead of convergence, this way, they flow parallel to each other. Such a temporary front, such a front is known as a stationary front. Now, if you remember, I told you geographically it is not a front, but we like classification, we like simplification. So, what name to give to such a temporary phenomena? We gave the name of a stationary front. So, what is a stationary front? What is the stationary front? It occurs when two contrasting air masses flow parallel to each other. Occurs when the two contrasting air masses flow parallel to each other. Obviously, koi weather pattern will not be there because there is no convergence. So when there is no convergence, there is no question of rising or descending air. When there is no question of rising air, there is no question of rainfall. So stationary front is a small. There is nothing not much important, but because when you are writing the classification of a front, obviously you should mention it in the examination. And obviously the diagram should be there. That is, what will be there on the ground surface. If this is a ground surface, this is the diagram for the stationary front. There will be warm air will flow in this direction. And the cold air will flow in opposite direction. So they are two contrasting but converging air masses, but because maybe due to the shifting of wind belt or due to some local phenomena, instead of converging, they are flowing parallel to each other. So this is a diagram for stationary front. Diagram for stationary front. It is a temporary phenomena. Again, due to changing weather pattern, this air will change their direction and they will start convergence. Now, where do the fronts occur? Fronts occur in the areas of subpolar low pressure belt. What is the significance of the fronts? The fronts result into the formation of an temperate cyclones, and these temperate cyclones are the major source of rainfall in the higher latitudes. Lower latitudes, जैसा higher latitudes में there is no low pressure belt. Like high heat and humidity, equatorial regions जैसा convectional heating नहीं है, because there is no that much heat also. There is no phenomena of like Himalayas, and therefore no phenomena like monsoon or shift in the wind direction. But rainfall is essential for life. So for rainfall, they have to depend on the temperate cyclones. When are these temperate cyclones formed? They are formed due to fronts, due to the convergence of two air masses. The next topic we are going to do the temperate cyclones. Now, the temperate cyclones, are it related to India? Yes. In the next topic, we will see that during the winter season, the fronts are formed along the Mediterranean Sea region, that is in this region. This is Africa. So there is a formation of the fronts in this region. This is the Himalayas. The fronts are formed in this region because of the shifting of the pressure belts. All the wind direction shift southwards, and therefore there are temperate cyclones, and fronts are formed in around the Mediterranean Sea region, in this region. They pick up moisture from this region and they blow towards India. After coming towards India, due to the presence of Himalayas, they are diverted either to the north and to the south. Yahan pe they give snowfall, and down they give rainfall. So in northwest India, in the states of Punjab, Haryana, Delhi region, Rajasthan region, they give rainfall, which is known as western disturbances. While in the Himalayan region, they give snowfall. So obviously they affect the winter pattern, they affect the rain pattern of weather pattern in India also, the fronts. So this is the fronts and the temperate cyclones, which we are going to study in detail in the next topic. But just keep in mind that this phenomena occurs, it is known as an western disturbances. Obviously I am going to take it in much detail in the Indian geography part, and we'll discuss what will be the question and what questions have been asked. But till now, what we have studied is the front. In the fronts, we have studied what are fronts. That is definition of a front. We have studied the conditions for the formation of a front. We have studied the classification of a front. And in the classification also we have studied the weather patterns which are associated with the formation of a fronts. For mains examination, it is a very simple topic, very simplistic diagrams. Also for the preliminary examination, there are some points which you should remember: contrasting and converging air masses. So these are the two conditions necessary. Therefore, the fronts are formed only in the subpolar low pressure belt, where there is a contrasting and converging air mass. On the other hand, in the equatorial low pressure belt, even though there is a converging air mass, fronts are not formed because they are not contrasting. Classification: cold front, warm front, occluded front. Weather pattern: cold front, cumulonimbus clouds, heavy rainfall for shorter duration, covers a smaller area. Warm front rises slowly, gentle slope. Cold front is associated with the steep slope, warm front is associated with the gentle slope. As a result, nimbostratus clouds, drizzle or moderate precipitation of a longer duration. Occluded front means the death of a front when the cold air totally displaces the warm air from the ground surface. Stationary front, it is a temporary phenomenon when the contrasting air mass, again remember the contrasting air mass, flow in the opposite direction parallel to each other. Now weather pattern, they result into formation of an temperate cyclones, and these cyclones also affect India. So this is what we have studied in this lecture. Revise, study very hard. Wish you all the best. We'll meet again very soon. Thank you very much.